Hey everyone, today we're going to continue on with section 7.3, and really this section is going to put together kind of everything that we did in 7.3 day 1 and then pulling in what we did in 7.1. So our main goal for today is to be able to figure out if two triangles are similar. So provide the reason, whether it's AA, SSS, or SAS, and then to be able to use the fact that they're similar to solve for a given side of the triangle. So again, that's just really what you did in 7.1 was setting up those proportions. So we're going to start here with number 1. And again, the first thing we have to do is actually prove that these triangles are similar. So we know we have 3 methods to do that. I'm just going to write them here: AA, SSS similarity, and SAS similarity. So if I'm looking at my first picture here, I notice that I know two side lengths of this triangle. I have 3 of this triangle. So right away I know it's not going to be SSS because I don't know the third side of this triangle. The other thing I realize is that I have a pair of congruent angles because of my vertical angles. So again, you would not have to write this, but I'm just making note of why I know those are congruent. So I know vertical angles are congruent, so this could potentially be SAS. So what I'm going to do now is see if my sides are proportional. So now when I'm looking here, UZ is the shortest side of this little triangle. So that should correspond to the shorter side on this triangle. So I'm going to check the ratio of UZ to ZY, and I'm going to see if that's the same ratio as VZ to ZX. And if those are proportional, then I'll know these triangles are similar. So UZ I know is 10, ZY is 25, then VZ is 14, and this is 35. So this ratio, I can divide both sides by 5, so that's going to reduce to 2/5. And again, you can always check that in your calculator. Here, I can factor out 7, so if I divide by 7, I'm going to get 2/5 as well. And so since I have corresponding proportional sides and a congruent included angle, I know these are similar by SAS similarity. And for my statement, I'm going to do triangle ZUV. So let's see, going from the short side to the other side. So it's going to be not congruent. Sorry, I'm making all sorts of mistakes here. Is similar to triangle ZYX. Okay, now the last thing I need to do is solve for this missing side, XY. So again, we're going to use a proportion to do that. And I'm just going to call side XY X for right now. So I know that the ratio of UZ to its corresponding side ZY has to be equal to the ratio between UV and my unknown side, which I'm calling X. So again, UZ is 10. ZY is 25, UV is 16, and then I'm solving for X. So I'm just going to solve this by cross multiplying. So I get 10X is equal to, let's see, 25 times 4 is 100, times 4 is 400. So if I divide by 10, I get X is equal to 40. So X is my missing side, so XY, that length, is equal to 40. So again, there's nothing really new here. We're just putting it all together. Okay, let's look at the next one. All right. Now, there's a couple ways I could go with this one. I noticed here, let's see, it almost looks like I could do side angle side. What we really have here is we have 2 overlapping triangles. So I have RSV. And then I have RT, and this is U. And so I know that this angle and this angle are congruent. It almost looks like we could do side angle side. However, we don't know this whole side RT on the big triangle. So side angle side isn't going to work. However, what I know is since these triangles share angle R, right? Angle R is congruent to itself by the reflexive property. So now I know that I have two pairs of congruent corresponding angles, so I don't even need to check side lengths. Our reason is going to be angle-angle similarity. And I'm going to write triangle RSV is similar to triangle RTU. So now I'm going to set up some proportions here. I am trying to solve for RT. So I'm going to fill in what else I know. I know RS is 10, I know SV is 8, and TU is 12. So I know that the ratio of RS to RT is equal to the ratio of SV to TU. So plugging in those numbers, I get, let's see, am I in the screen? Yes. 10 over X is equal to 8 over 12. So 8x is equal to 120, and if I divide there, I get x is equal to 15. So that missing side length RT is 15. Okay, go ahead and flip the page. I think we've just got a couple more examples. All right. Number 3. So again, I'm trying to figure out how these triangles are similar. So I don't have enough information about sides to either do SSS or SAS. So I know I'm looking for AA similarity. So right away, I pick out my vertical angles. And then what I also know is that AC is parallel to ED. So if I look at my transversal CE, I know that angle C and angle E here are going to be congruent, because if parallel lines, then alternate interior angles are congruent. So now I've got two pairs of congruent corresponding angles, so I'm similar by angle-angle similarity. My statement, I know triangle ABC is similar to triangle, let's see, ABC would be DBE. All right, and then last, we're going to go ahead and solve for segment BE. So I'm just going to call that X. So let's see what length we have. I know that segment AB, the ratio of that length, now AB corresponds to DB. I'm using my statement there. That ratio has to be the same, let's see, as BC to BE, which is what we're trying to find. So AB, that length, is 36. DB is 54. BC is also 54. And then we have X. So I'm going to cross multiply again, solve this proportion. So 36x equals, let's see, 54 times 54 is equal to 2,916. If I divide by 36, I get x is equal to 81. So segment BE, that length is equal to 81. All right, last example. And this one's a little bit hard to see. Actually, it's a little better on the camera than it looks on my page. But here's what we have. Again, I have two overlapping triangles. This one is BFG. And then I have a big triangle, ABC. And I know that FG and AC are parallel. So what I really know then, if I'm looking at my big triangle here, I know by the reflexive property that angle B is congruent to itself. Now, if these two sides are parallel, I can look at my transversal AF, and I know that this angle A is going to be congruent to angle BFG. And again, the reason for that is if I have parallel lines, then in this case my corresponding angles are congruent. So these are going to be similar by angle-angle similarity. That's been a popular one today. And again, if I mark it here, again, this is because of the reflexive property. And then these are my corresponding angles. So I know that triangle FBG is similar to triangle ABC. Now, if I mark what I know, it looks like this is 6.5. This is 24. And it looks like the whole length of the big triangle is 17 here. And I'm trying to find BF. So again, I know that BF corresponds to BA. That ratio has to be the same as the ratio of FG to AC. So I have x over 17. Sorry, I've gone off the page again. X over 17 is equal to 6.5 over 24. So now if I cross multiply, 24x is equal to 6.5 times 17, 110.5, and then if I divide, I get x is about 4.6. Oh, I did this wrong. You know what? I'm going to have to take that back. That 17 is only this piece of the triangle. Since I'm finding BF, this is actually 17 plus x. This segment here is an unknown piece x. So that whole side has to be 17 plus x. So I apologize, guys. I'm going to cross this off. And let's take a look again. So what I really have is x is to 17 plus x. That's equal to 6.5 over 24. So now I'm going to cross multiply. I have 24x equals 6.5 times 17. That gives us our 110.5. But I have to distribute that 6.5, so plus 6.5x. Now I'm going to combine all of my x's. Let me focus this a little bit, see if I can do better. Okay, so 24 minus 6.5 is 17.5x equals 110.5. So now I'm going to divide. And I get x equals 6.3, approximately. Okay, so then BF there is 6.3 feet. So I apologize for that error there. All right, so that's it for today. We'll be doing some practice. You'll be doing a little Mad Lib activity to practice some of these problems in class tomorrow. See you then.